Welcome to our lesson today. We are going to start with a review of molarity. Molarity is the concentration in moles per liter. Concentration in moles per liter. And to that end, we can only find molarity by dividing. Okay, we cannot convert our way into molarity. In the mole unit, we convert a lot of things, but for molarity, in order to find concentration in moles per liter, you must take moles and you must divide by liters. Okay, so even if you're doing a conversion somewhere else, remember that in order to find the molarity, you must actually divide. So let's say, for example, you had 3.76 times 10 to the 22 HCl molecules, dissolved molecules, MC, not M, dissolved in 25.0 milliliters of water. So if that's the case, we want to know what is the concentration of HCl. Don't forget square brackets around the substance means find the concentration. So we need to have concentration of HCl is equal to moles of HCl over the liters of solution. And we ask ourselves, do we know the liters? Well, yes, we do. We know that we have 25.0 milliliters and 25.0 milliliters. A couple ways you can change that. It is okay for you to simply move the decimal 1, 2, 3 places over. I'm going to assume that you can do that successfully. If you can't, then make sure you use the conversion factor method that I will show you in just a moment. However, right now I'm just going to plug this in here, 0.0250 liters. If you did get that wrong, if you're moving your decimal place the wrong way, or if you're moving it the wrong number of places, you can always show your conversion this way. How many liters is 25.0 milliliters? And you can say I need to cancel milliliters and find liters. And I know that there are 1,000 milliliters in 1 liter. So 25 divided by 1,000 is 0.0250. Don't forget, this 0 here means that you must have this 0 here as well. Okay? Oops, I forgot my unit on the end there. Well, that's very nice, but I need to have my moles of HCl. Right now, I only have molecules of HCl. So, what are my moles of HCl? Well, I know I can convert between molecules and moles using Avogadro's number. 3.76 times 10 to the negative 22 HCl molecules times 1 mole per 6.02 times 10 to the 23 molecules. And we get just finding my calculator here. 3.76 e negative 22 divided by 6.02 e 23 equals, and we get 6.2458 times 10 to the negative 46. Now you'll notice I have kept 5 digits here. That's because I want to take this number and plug it into another calculation all the way up here. I don't want to round off this number because I could end up with a rounding error. So anytime you're using one number from one calculation in a second calculation, make sure you don't round it off. Always keep a couple extra digits past your sig figs. In this case, we have 3 sig figs, so keep a couple extra for 5 digits. Plug that in. We have 6.2458 times 10 to the... Oh, I've done something so bad. That's not a negative 22, that's a positive 22. And do you know how I know that? I know I should have like a largish number of moles. I should not have a negative 46 number of moles. So let's get rid of that negative 46. Blah, there we go. So now let's try that again. We have 3.76 times 10 to the 22 divided by 6.02 times 10 to the 23 equals, and that looks like a much nicer number. We have 0.06248 moles of HCl. So again, we're going to plug that up into our moles of HCl. So we now have 0.062458 moles divided by 0.0250 liters. 0.025 equals, and we get 2.4983, which will round to 2.50 molar. And because I've got so much going on, I'm going to box my answer, and I would probably also highlight it and put a star and say answer, because it's not at the end, right? So if I was being really kind to a marker, I'd be like, here's my answer right here. Star that sucker.